You're welcome back to my channel. We continue calculation on quantitative analysis for 2025 WAEC chemistry practical. In my past video, I've explained how to manipulate your Biret reading table based on your teacher's title value without carrying out the experiment. Then I've also explained all the necessary rules and regulations that need to be followed while answering questions on quantitative analysis. So in this video, we are going to solve another questions on quantitative analysis different from the one we solved in my past video. Then don't forget that all these questions are predicted questions. They are not exact questions that will come out. They are predicted questions. Then we are going to use the table manipulated from the first video to solve this question. Then don't forget that I told you in the first video that the first thing that you need to write before you form your table is the volume of pipettes used. The volume of pipettes that you are using in your school. Your pipette is in this form. Your pipette is in this form. Go and check the volume of your pipette. Check the volume of your pipette, and or you ask your subject teacher that what is the volume of your pipette. So the first thing to write on the table is the volume of your pipette used. So my own is 25.00 centimeter cube. So your volume of pipette is the same thing as the volume of base. Is the same thing as the volume of base used. Then our base for this year 2025 is sodium hydrogen thiazocarbonate. This is our base, while hydrochloric acid is our acid. So therefore, the volume of your pipette is equivalent to the volume of my base. So therefore, the volume of base, which is VB, V means volume, B is the base. So the volume of base is 25.00 centimeter cube, which is the volume of your pipette. So that's it. After this table, you can analyze all your words, all your parameters out. You can analyze all your parameters out. Then we have manipulated this table in the first video, so we are going to continue. We are still going to use this same table to solve this question. So after your table, the next step to take is to calculate the average volume of acid used. You calculate the average volume of acid used by using two concordant theta value. Then I explained in my past video that your concordant theta value must not exceed 0.1. Your concordant theta value must not exceed 0.1. So we don't always use rough theta in calculation. So your rough theta should not be included in your calculation. So I'm going to use the first theta and the second theta. So let's look at my first theta is 22.70. So my second theta is 22.60. So the difference of what is 0.1. So difference between the first theta and the second theta is 0.1, which is okay. So your theta value, your concordant theta value must not exceed 0.1. It must not exceed 0.1. If it is up to 2 or more than 2, 1 or 2 marks will be deducted from your mark. 1 or 2 will be deducted from your mark. So let's calculate the average volume of acid used. So the next step is to calculate the average volume of acid used. Average volume of A used. So my A is my acid, is equal to, so the first two concordant theta value, don't use your rough theta. So 22.70 plus 22.60 divided by, I use two concordant theta values, so divided by 2. So which is equal to 22.65 centimeter cube. So don't forget to put your unit. So my unit is centimeter cube. So the average volume of acid used is 22.65 centimeter cube, which is the same thing as volume of acid used, which is VA. So the volume of acid used is the average volume of acid used. So equal to 22.65 centimeter cube. So after this, then you go back to your questions. So A contains 3.92 gram. A contains 3.92 gram of hydrochloric acid in 1 dm cube. So it shows that it is gram per 1 dm cube. Then I explained in my last video that anything in gram per dm cube, anything in gram per dm cube is your mass concentration. Is your mass concentration. So a value in gram per dm cube will be your mass concentration. So when you see mole per dm cube, that will be your molar concentration. Then when you see mole, gram per mole, another one is gram per mole, that will be your molar mass. Your molar mass. So to access my past video, if you are new here, kindly subscribe to Royal Learning channel so that you can have access to my past video on quantitative analysis. So anything gram per dm cube is your mass concentration. So mole per dm cube is your molar concentration, while gram per mole is your molar mass. So this 3.92 gram per 1 dm cube is the mass concentration. Anything gram per dm cube is the mass concentration. So mass concentration of what? Of hydrochloric acid. That's my mass concentration of acid. So I'm going to write mass concentration of, please write your concentration fully. Mass concentration of A is equal to 3.92 gram per dm cube. Per dm cube. So let's read further. B is a solution containing 12.6 gram of a mixture of NaCl, that's sodium chloride, and sodium hydrogen triisocarbonate. So that is, B consists what? Of a mixture of sodium chloride and sodium hydrogen triisocarbonate. Normally, our base is sodium hydrogen triisocarbonate because this here titration is on sodium hydrogen triisocarbonate and hydrochloric acid. So sodium hydrogen triisocarbonate is our base, while hydrochloric acid is what? Is our acid. So it's acid-base titration. So, but we are having a mixture of sodium chloride and our pure base, which is sodium hydrogen triisocarbonate. So this one will be an impure. NaCl is an impure in the mixture. So it's an impure in the mixture. So therefore, this 12.6 gram will now be the mass, the total mass of the pure. This is pure. Our sodium hydrogen triisocarbonate, which is our base, is pure. Will be the mass of pure and the mass of what? Of impure. So we are going to write mass of mixture. Mass of mixture, or you call it mass of impure. Mass of impure NaHCO3, because this NaCl is an impure in the substance, so it's equal to 12.6 gram per dm cube. 12.6 gram per dm cube. Now, from your results and information provided above, that is information provided from the titration above, which is your table, calculate the concentration of base. Our base is NaHCO3 in what? In mole per dm cube. Anything in mole per dm cube is my molar concentration. So I'm looking for the molar concentration of base. So my molar concentration of base is the same thing as Cb. Let me write here because of the space. So my Cb is unknown. I'm looking for the molar concentration of base, which is my Cb. Now, we have two formulas. we have two formulas to look for molar concentration. The first one is your general formula, Ca Va over Cb Vb is equal to Na over Nb. This is the first formula. Then we always use this formula to look for either the molar concentration of acid or the molar concentration of base. C means molar concentration, A means acid. So that's molar concentration of acid. Then C, molar concentration of base. V, volume of acid. V, volume of base. N is the number of mole of acid. Then Nb will be the number of mole of base. So the number of mole of acid and base will be gotten from your what? From your chemical reaction. Now, I'm looking for Cb. Cb is my unknown. Now, do we have the molar concentration of acid? Is there molar concentration of acid from our parameter written out? No. We have only mass concentration of acid. So there is no molar concentration of acid. Then at the same time, we are looking for the molar concentration of base. So it shows that this formula will not work first. It will not work for you to look for the what? Cb, because we have two unknown. So it means that since we are looking for Cb, we have to look for Ca. We have to look for Ca. So there is another formula for calculating the molar concentration. There is another formula for calculating the molar concentration, which is equal to molar conc, molar concentration. Please don't write conc, write it fully. Molar concentration is equal to mass concentration divided by the molar mass. So it shows that I have to look for the, since I have the mass concentration of acid, so I can look for the molar concentration of acid. I will just need to look for the molar mass of acid. So what is the molar mass? Molar mass of, so my acid is what? HCl. My acid is HCl. So the molar concentration of HCl equal to the mass of hydrogen, the molar mass of hydrogen, or the atomic mass of hydrogen, which is 1, plus the atomic mass of chlorine. The atomic mass of chlorine is 35.5. So it will give me 36.5. So 36.5 what? The unit. We are talking about molar mass. Molar mass must be in gram per mole. So your unit is gram per mole. Your unit is gram per mole. Then that is not where we are going. We want to calculate the molar concentration of acid. So from there, we'll be able to look for the molar concentration of base. We want to calculate the molar concentration of acid. So now we can come back to the molar concentration of acid now. Then we say molar concentration of acid is equal to, so that is mass concentration, and I have mass concentration of acid, which is 3.92 divided by the molar mass of acid. Then what is the molar mass of acid is 36.5. 36.5. So 3.92 divided by 36.5 will give me 0.102 equal to 0.102. Then anything molar concentration must be in what? In mole per dm cube. So I've gotten the molar concentration of acid. Then I'm looking for the molar concentration of base. The first question says that calculate the molar concentration of B, which is my base. So let's come back to the base now. Now I'm looking for the molar concentration of base. Then the molar concentration of acid can also be written as Ca. that C means molar concentration equal to, so I've gotten my molar concentration of acid to be 0.102 mole per dm cube. Then I'm looking for the molar concentration of base, which is Cb, is unknown. Then I have the volume of base. My Vb from this place is 25.00 centimeter cube, which is the same thing as the volume of your pipette. Then my Va is equal to 22.65 centimeter cube, which is the same thing as the average volume of acid used. Then to use that general formula now, I need general formula to look for Cb. So I need the number of mole of acid. So the number of mole, Na, is equal to, so you come back to your chemical reaction. The coefficient of acid here is 1. So the number of mole of acid is equal to 1. The number of mole of base will be the coefficient of your base. Your base is sodium hydrogen triisocarbonate. So the coefficient is 1. So therefore, you can use your general formula, which is Ca Va over Cb Vb equal to Na over Nb. Then you are looking for Cb. So the next step to take is to make Cb the subject of the formula. Don't jump any step. So I'm looking for Cb now. I will make Cb the subject of the formula. So my Cb will then be equal to, by the time you cross multiply, will be equal to Ca Va, then Nb divided by VBNA. So the next stage now, my Cb will now be equal to, so what is Ca? Ca is 0.102. 0.102 times my Va. My Va is 22.65 multiplied by 22.65 times my Nb is 1, then divided by my Vb is 25.00 times 1. So Cb will be equal to, so what will be the final answer for Cb? So by the time you use the what you have up to divide what you have down, you are going to get 0.092 mole per dm cube. So make sure that your molar concentration is in either 2 to 3 significant figure. Make sure that your molar concentration is in 2 to 3 significant figure. So if what the values that you have are more than 3 significant figure, use 3 significant figure. So if they are not up to 3 significant figure, you can use 2 significant figure. So my molar concentration of B is now what? Is 0.092 mole per dm cube. So we have answered Roman figure 1. So let's move to Roman figure 2. So Roman figure 2 says mass of Na, calculate the mass of NaHCO3 in gram per dm cube. Don't forget that this mass is mass of an impure, not the mass of NaHCO3. So it's the mass of both sodium chloride and sodium hydrogen triisocarbonate. So we cannot use this one as the mass of NaHCO3. It's the mass of an impure. So we need to look for the mass of impure. Then we can only use this formula to calculate the mass concentration in gram. we can only use this formula to calculate the mass concentration in gram. So I'm looking for the mass concentration now. Roman figure 2. I'm looking for the mass concentration. From this formula now, I will make mass concentration the subject of the formula. When you cross multiply your mass concentration equal to your molar concentration times your molar mass. Molar concentration multiplied by the molar mass. Then our molar concentration of B, we have gotten the value for molar concentration of B, which is 0.092 mole per dm cube. So we are looking for the mass concentration of what? Of B. We are looking for the mass concentration of B. Mass concentration of B. So we are going to use the molar concentration of B. So which is equal to, then let's check. We need molar concentration of B. Then our molar concentration of B is 0.092 mole per dm cube. Then likewise the molar mass of B. So our B is sodium hydrogen triisocarbonate. So we have to look for the molar mass of B. So molar mass of NaHCO3 equal to the mass of sodium, which is 23, plus the mass of hydrogen, then plus the mass of carbon. The mass of carbon is 12, plus the mass of oxygen. Then we have 3 atoms of oxygen. That will be the atomic mass of oxygen is 16, then times 3. So everything will give us 23 plus 1 plus 12 plus 16 times 3 will give us 48. So let's add everything together. So 12 plus 48 will give us 60. 60 plus 23 will give us 83 plus 1 will give us 84. So therefore our molar mass is 84. Then anything molar mass must be in gram per mole. Your unit is very important. No mark for no unit. So when we are going, we are looking for the mass concentration. We are looking for the mass concentration of B. So therefore, mass concentration of B equal to, don't forget, don't write conc, write it fully, is concentration. So the mass concentration is now the molar concentration of B. We are looking for B, the molar concentration of B, which is 0.092. 0.092 multiplied by the molar mass, of B. So we have gotten the molar mass of B to be 84. So multiplied by 84. So which is equal to, so 0.092 times 84. 0.092 times 84 will give us 7.73. The mass concentration must be in gram per what? Per dm cube. Must be in gram per dm cube. So that is the mass of NaHCO3 in the mixture. So let's move to Roman figure 3. Let's move to Roman figure 3. Then Roman figure 3 says, calculate the percentage by mass of NaHCO3 in the mixture. We are looking for the percentage by mass of NaHCO3 in the mixture. So NaHCO3 is our pure substance. So that is the percentage purity. percentage purity because this is pure. Then the sodium chloride is an impure in that mixture. Sodium chloride is an impure in the mixture. So since we are looking for the percentage by mass of NaHCO3, which is our base, that is the what? Percentage purity. Then what is the formula for calculating percentage purity? Roman figure 3. Percentage purity, or we are looking for the percentage by mass. Let's call it the percentage by mass of NaHCO3. So we are going to use formula for calculating percentage purity. So which is the mass of pure divided by mass of impure. Mass of an impure times 100 over 1. So the mass of pure sodium hydrogen triisocarbonate is our pure. So what is the mass concentration of sodium hydrogen triisocarbonate? That is 7.73. So the mass of pure is 7.73 divided by the mass of impure is the mass of mixture. So which is 12.6 times 100 over 1. So what will be our final answer for that? What will be our final answer for that? That's it. It will give us 61.35. 61.35%. Since we are looking for the mass of what? Mass of pure. That is mass of NaHCO3. And they call it what? The percentage by mass of NaHCO3 in the mixture. So the next one is to calculate the mass of NaH. Okay, Roman figure 4. Calculate the mass of sodium chloride in the mixture. Calculate the mass of sodium chloride in the mixture. So it will be the total mass, that is the mass of impure minus the mass of pure. So the mass of NaCl, Roman figure 4. Mass of NaCl in the mixture will be equal to mass of impure minus mass of pure. So which is equal to, so what is the mass of impure? That is the mass of the mixture. So the mass of the mixture is what? 12.6 gram per dm cube. So 12.6 gram per dm cube. Let's say 12.6 minus the mass of pure. Our pure substance is the mass of our base. So which is 7.73 minus 7.73 will give us what? So let's solve that one out. 12.60 minus 7.73. 10. That will be 7, 6. Carry 1. That will be 15. 15 take away 7 will give us 8. 11 take away 7 will give us 4. So it will give us 4.87 gram per dm cube. So that is the mass of sodium chloride in the mixture. The mass of sodium chloride in the mixture. Then finally, the last question on this aspect says, calculate the number of hydrogen ion in 1 dm cube of A. Calculate the number of hydrogen ions. So we go back to our mole concept. We apply mole concept. So we are going to apply mole concept formula. Then we are looking for the mass of what? Of hydrogen ion in 1 dn cube of A. That is in 1 dn cube of our acid. Then this is our acid, hydrochloric acid, HCl. So we are going to write dissociation of what? Of acid. That's HCl. HCl will dissociate to, how many elements do we have here? We have hydrogen. So it will dissociate to hydrogen ion and chlorine ion. It will dissociate to hydrogen ion and chlorine ion. So how many hydrogen here? 1. How many here? 1. How many chlorine here? 1. How many here? 1. So balanced. So it shows that 1 mole of hydrochloric acid, 1 mole of hydrochloric acid will produce 1 mole of hydrogen ion. 1 mole of hydrochloric acid will produce 1 mole of hydrogen ion. Then 1 mole of any ion, 1 mole of any ion is equivalent to what? Avogadro's constant. 1 mole of any ion or molecule is equivalent to Avogadro's constant. So our Avogadro's constant is equal to what? 6.02 times 10 raised to the power 23. So it will be given in the question. So we are going to come back to this ionic equation now. We are going to say 1 mole of our acid, which is HCl. So 1 mole of HCl of acid produces what? 1 mole of hydrogen ion. Produces 1 mole. That is, the coefficient of this hydrogen ion is 1 mole. Then the coefficient of this hydrochloric acid is 1 mole, equal to 1 mole of hydrogen ion. So we come back here, then 1 mole of hydrochloric acid will now be equal to, so the number of mole of any ion, 1 mole of any ion equal to your Avogadro's constant. So this one will change to 6.02 times 10 raised to the power what? 23. But the question says that we should look for what? The number of mole of hydrogen ion in 1 dm cube of the solution. In 1 dm cube of the solution. That's mole per dm cube. Mole per dm cube. In 1 what? Dm cube of A. In 1 dm cube of A. Anything mole per dm cube, because they mentioned 1 dm cube now. So anything per dm cube, mole per dm cube is your molar concentration. So molar concentration of what are we talking about? The molar concentration of acid. The molar concentration of acid. Then what is our molar concentration of acid? Which is Ca. Our molar concentration of acid is what? Is 0.102 mole per dm cube. So we now say that is 0.102 mole per dm cube of HCl will now be equivalent. So we don't know the number of ion that will be equivalent to 0.102 mole per dm cube. So this is unknown, equal to X ion. So we cross multiply. So by the time you cross multiply, X times 1 mole will give us X. X will now be equal to 0.102 multiplied by 6.02 times 10 raised to the power 23. So which is equal to, so what would be our final answer for that? So it will give us 6.14 times 10 raised to the power 6.14 times 10 raised to the power 22. 6.14 times 10 raised to the power 22 ions. So that is the number of hydrogen ion. But if your question says calculate the number of hydrogen ion in maybe in 25 centimeter cube instead of what? Of 1 dm cube. If it says in 25 centimeter cube, so you are going to take your molar concentration of acid. You can convert your molar concentration of acid to mole. You have to convert your molar concentration of acid to mole. If your question says that calculate the number of hydrogen ion in 25 centimeter cube instead of 1 dl cube. This is what we are going to do. If your question asks you to calculate in 25 centimeter cube, so you are going to take your molar concentration first. You calculate the number of mole. You say mole, the number of mole equal to molar concentration, molar conc, multiplied by your volume in dm cube. So you will convert first. You have to convert it first because this is what? Per centimeter cube, not per dm cube. So it will now be, your molar concentration is what? Is 0.102. That will be 0.102. Then times the new volume now, not in dm cube, is in 25 centimeter cube. That will be 25. 1 dm cube equivalent to 1 dm cube is equivalent to 1000 centimeter cube. So to convert this 25, if it is 25 to centimeter cube, you divide it by 1000. So whatever you get here, that is what you are going to use to multiply your Avogadro's number. So let's assume that our answer here is 0.00234. Let's assume that this is our answer for this. So you are not going to use this answer to multiply what? The number of hydrogen ion will now be, sorry, it's because of the space. I'm trying to manage the space. So to calculate the number of hydrogen ion will now be your what? The number of mole that you have converted now, which is 0.0234, multiplied by my Avogadro's constant, 6.023 times 10 raised to power 23. So whatsoever you get will be the number of what? Of hydrogen ion. That is when your volume is in 25 centimeter cube, not in what? In dm cube. So they can replace it with any value. They can replace your volume with any value. But when it is in 1 dm cube, just use your Avogadro's constant to multiply your molar concentration. Use your Avogadro's constant to multiply your molar concentration. But when it is not in dm cube, you have to convert your molar concentration to what? To dm cube before you multiply by your Avogadro's constant. Then don't forget to follow all the necessary steps, all the necessary rules and regulation. Your question will not exceed what we have solved together in the first video and in the second video. Not exact, but it will not exceed what we have solved together. For further information, you can DM me on +234 8128 62 4004 +234 8128 62 4004. See you in my next video. In my next video, I'm going to explain the last aspect of this practical, which is qualitative analysis. Bye.